Alright, hello out there in TV land. This is Noah Vaughter from DIYDSP.com. And tonight I'm coming to you live from the Framingham Makerspace. So if you hear any sounds going on in the background, that's people making things, some machines. Right now my buddy Kyle is working on something, drilling through some metal. Maybe he'll drop by and say hi in a bit. But anyway, what we're going to do tonight is resume the electric eel restoration. In this series, if you've been with us, or if you haven't been with us, I pulled one of the instruments that I designed from storage a few weeks ago. And it hadn't been played in years, and I found that it was actually in a few different pieces, and it definitely didn't work. So if you go back and you watch the videos, you'll see what we've done together to bring it back to life. I found there was one dead chip, and that was replaced. And one of the big problems is there's a missing keyboard. I just haven't been able to find it. So I actually had to go on to Eagle, the circuit board program, and design something new. So this is a picture of the keyboard. Oh cool, we've actually got somebody watching live with us. Hello. I can't see the chat because I'm on my phone, but welcome. So this is a picture of it. And this is always fun when the circuit board from Osh Park arrives at the same time as the switches. So first of all, let's do the unboxing here. Got any scissors nearby? Let's just rip into it. So if you don't know, then Osh Park, OSH Park, is a great little website where you can upload designs you build with Eagle, which is free. And they'll make them in very small quantities for you. So they're good for testing things out, developing them. Look, they sent along some free jelly beans. Nice. Too bad I don't like sugar that much, but anyway. All right, here we go. This is the part that I received, and it looks pretty much exactly like they said it would. So what is it? This actually holds 4 keyboard switches, and you play it pretty much like this. You hold one finger over every key, and I actually ordered 3 of them. Most electrical eel keyboards have 8 switches, and you play it like that. Each one gives you an octave. This one I decided, hey, we're restoring it. Let's add a 3rd one and get to 3 octaves. And I did that because over the years of playing other keyboards, other electric eels, I found that a lot of songs, they just barely fit into the 2-octave range. So getting that 3rd is going to let us play Have a Holly Jolly Christmas, because you have to go down to this B. All right, so let's open up our other box here. This has the keyboard switches in it, which look like this. These are cherry switches. So if you didn't know, the cherry switches come in different, pressures and different feels. Some make a click. So for this one, I've ordered the quietest possible ones. And these are the keycaps. So the keycaps are what actually goes on top of the switches. And one of the pieces of feedback I got, I believe it was from Pink Noah at the MIT Media Lab, was that they didn't like that the switches were actually concave. That means because you couldn't run your fingers up and down them as fast as you can flat switches like a piano. So I've tried to find some that were actually convex or flat, and it's harder than you think. Options are a little bit limited. But the good news is, since that time, 3D printing has really come through. And what my plan now is to use these switches in this rev here, and then go in 3D print and design some that are more like real keyboard switches. So that'll be pending. But let's just get the thing working at first. Okay, so here are my Cherry MX switches. I got the red kind, so let's press it and see. See if I can get that to focus. Oh, now I see the chat. Hey, hey, AKA Medium, how are you? Yes, definitely want a 3D print. Okay, so I can't focus this camera right now, but the nice thing is the press is very light, just like I was hoping. Because when you play, you know, an instrument, you want to be able to play fast. So let's just make sure that they fit into here. Yeah, looks good. All right, so next part of this video is I got a soldering iron set up, and I'm gonna solder through all 12 switches on all 3 boards. So that's gonna take a few minutes here. I'm just making some space. I'm sitting down, get comfortable. Pour ourselves out a few of these switches. 3, 4, 2, 3, 4. And I got a few extras. So who knows what the future holds. Put them all in. So this is a very simple circuit board. It's literally just switches, no capacitors, resistors, or anything. The only other features on there are the solder pads 1 through 5, where we actually connect it to the microcontroller. I'll show you that later. It's just straight through wires. And then I added these 2x6 headers on there that's so I could daisy chain these all. Because normally you have to wire, these are actually set up in a 3x4 matrix. So you have to wire all 4 of those. You have to wire them all in parallel. So I figured, why not just make these little 2x3 headers, and then I can use board-to-board connectors instead. And then I'll just like save a little time and it'll be a little more organized. All right, where's my solder? So I've got my trusty Heiko soldering iron that was donated to the Makerspace by Jim from MathWorks, also formerly of Meteor Lab. How you doing, Jim? Thanks for the soldering iron. Gets a lot of use here. No. I know my current live audience has a lot of experience soldering. I'm seeing his many projects over the years. But if you're watching this later than the live stream, you know, it could be months or years from now, and you want to know anything about soldering, oops, I can give you just a few tips. First of all, you don't want too much heat. I'm using 700 degrees here. And I usually think of it as the junction of 3 different parts. I think of the 2 things that you're going to solder together. Actually, it's 4. Then there's the heat. Take a look. Oh yeah, this is going to be good. Let's put some keycaps on already. So if you don't know how keyboards work, this is also pretty instructional. If you look close at these, I know it's blurry. I'm sorry, I can't figure out how to focus this camera. It's just my little cell phone. But there's a little plus shape on there. And then this is a keycap. And it's also got a little plus shape inside it. So all you do is you line them up. And you press. Not exactly rocket science, but good to know. That's 2. Boop. Oh yeah. Pretty exciting. And then you're going to play it just like this. Now remember in the previous video I mentioned how the scale goes. It's real easy. It goes C, E, G, B. How do you get to the notes in between? Well, if this is C and this is E, D is in between, so you hit both of those. This is E and this is G, so F is in between. Oh yeah, that key feels real nice, real fast. And then A is between G and B. Boop. So you go C, D, E, F, G, A, B. And then also there's secretly a C up there too. And you may ask, how do you get to the chromatic notes? Well, if you're C, you go up to C sharp. If you're at B, you go down to B flat. If you're at F, you can go up to F sharp. Likewise, if you're at D, you can go up to D sharp there. There's only one weird exception, that's G sharp, which just happens to be all of them. Sorry, there's no other real way to do it, but I'll tell you, what I found in my research is that musicians, people who already play a music instrument, can pick up a fingering very quickly. It's almost scary how quickly they figure it out. And furthermore, you can give them an almost arbitrary set of finger combinations and they just pick it up very fast. A number of people in my experiments back in the day did that. You will notice that I left out 3-finger combos that are like this and like this, just because it's kind of hard to hold your ring finger up in the air. And then that one's also kind of less than preferred. It's a bad candidate for G sharp, because that's G. Anyway, let's solder together a couple more of these. And then I'm going to try to add it. You see I got the rest of the instrument in the background here. Try and hook everything up together and see if it all works. So first I'll place these on. That's a failure. How did I do it last time? Oh, it just seemed to work. Sounds something like this. So anyway, I was talking about soldering technique for anyone out there in TV land. What I like to do is heat up the 2 parts that I want soldered together. Just put the soldering iron on them equally. Just like that. Once it's warm enough, all you have to do is just... It's just not working out. Like that. Dab the solder on and boom, it holds. Put that away. Coordinated tonight there. Okay, well, that seems to work. So hold the soldering iron there, touching both. Both parts are warm. Dab the solder right in. And it holds. Let's go back and fix that one. My hand's blocking that, so let's do a camera reorientation. By the way, to make the keyboard switches in Eagle, I couldn't find a part, so I had to draw my own. If anyone is interested in making a keyboard, I'm sure it's out there somewhere. I just didn't locate it. If anyone's interested, let me know and I can send it over or post it or something. It's obviously a real simple part. It's just got a couple of holes for alignment and 2 terminals. But it's nice to know that it's measured properly and it's just going to work when you open up your parts. Okay, number 2. Let's attach the keycaps. So there are a few other features of the keyboard while we're at it. These circles around there, those are for mounting. So you can use a small screw and some standoffs. And they're located, I don't have the measurement in my head right now, but it's some even multiple of 1/10 of an inch. So now we have 2 of them. You see you're going to space them out. Oops. I'm going to space them out like that. I just got yellow to match some of the colors in the rest of the instrument, by the way. It's all red and got some nice flowers on there. I made a bunch of these during the spring. That's how I chose the design. I picked the season that we're currently in. I just use pictures from that season. So spring is when, what's the name of these crazy yellow flowers? I forget the name right now. It's not chrysanthemum, it's not rhododendron, it's not hyacinth or delphiniums. Some fancy kind of Latin style name. So I learned a little bit from last time. You know, I flipped them like that. Oh, 2 popped out. And I had another one in there. Let's see if that last one, the solder made contact. But if you look really closely, see, it was a crummy job because it's not flush with the board. So what you can do in cases like this is heat up the solder in the joint already. And push it through. It's just not enough solder in general. How do I do that? Okay, so now I'm pushing on it with my thumb. Okay, that's much better. See, it's flat now. I've actually messed that up on some other ones, and what happens is it makes it so the keycaps aren't flat. It makes it a little harder to play. It's one of those quality things that you want to look for. All right, so let's try this again. There we go. All right, got a good feeling about this. Still in the frame, yep. Another point in soldering too, you actually need a little bit on the tip to conduct heat. So just before I go on there, I'll just dab a little bit like that. Now the heat will go from the tip onto the joint. Then you apply the serious amount. Usually do a handful of connections. Ooh. Before that wears away. Okay, last one. Normally you'd have some kind of ventilation going so you don't breathe in all these solder fumes. I happen to be off to the side and kind of under the desk, so I'm out of the striking range. Oh yeah, baby. This is exciting. Let's put on the last 4 keycaps. One, two. Now, if you're wondering where I got the switches and the keycaps, I did some, whoa, springiness. I did some basic comparison shopping. There's a lot of different places. So if you want a decent deal where you can order them both, then I got it from this company here. Not showing you my address. Can you even see that? No, you can't. Anyway, it's called maxkeyboard.com. It's a good enough deal for what I'm doing. All right. I'm just going to do a little bit of cleanup here. Put that away. Whoa! Losing switches. Now I just like to lay these out and just observe my work, take it in for a minute, imagine what's going to look like. Can even go over to the instrument. Now this is the keyboard section here. So in the old instrument they kind of poked through. Not sure exactly how it's going to work in this one. I'm just going to get it mechanically working, electrically working first. They might just float up top here. As you can see, it's going to take more space than the old keyboard. So probably have to carve into this material again. This is some pretty thick postage mailing tube. Okay, that was part 1. So now part 2, I'm going to attempt to wire it up. So this is the CPU section here. This is the generator electronics. This is that regulator I fixed a few videos ago. And down here, whoop, this is the generator itself. This is the part that slides back and forth like that. it makes power. So what we're gonna do now, just focus on this part here. Let's try to wire these up. So this whole system was designed around these 2x5 type of connectors for ribbon cables. And this is your colorful ribbon cable. Everyone loves colorful ribbon cable. So let's, first we're going to break out one of these. If you've ever used this style of header before, it's got two halves. It's got all these teeth. Sorry about the focus. I'm not sure how this camera knows what to do. So let's break off some of this.
Yeah.
Howard. So yeah, so I've been looking for.
All right. So they're starting to do some tours in the background here. So here at the Framingham Makerspace, may have to cut it a little early, but let's count the conductors here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, check. We have 10 conductors there. So break off about 2 feet of this. Get some cutters in the drawer.
So that's our back.
Yes, nice. So
And I saw that you did Wednesdays. You did.
yeah, open house. That's what we-
Diagonal cutters, dikes.
Yeah, we're pretty low key around here.
Yeah, that's right.
So I'm just going to trim that there.
Okay.
That's 4 little conductors you can use for something else. And then I'm going to trim here.
Yeah, so actually, right now, Makerspace is going through a little bit of transformation because there's a new space that we just got around.
What is there?
So it's just there.
Okay, so this is originally wider, but I'm just going to count these again because I don't want to ruin the ribbon cable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. The only interesting thing is the colors aren't necessarily going to match up. I don't like that about this. Tell you what, let's make it easy on ourselves. I'm going to waste some material, but it's going to pay off in the reduced confusion in the near future. So cut this again. This is all designed around the brown being pin 1.
Over here we have some storage along here above the top.
Okay, so we're going to go from brown. So again, brown, red, orange. 5, 6, 7, 8, 9, 10. So there we go. Now if we look close on this board, first of all, for reference, this is the knobs board, and it's got the same 10-pin connector. So kind of see how that goes together. That's how the brown's all the way over here on the left side. Goes brown, red, orange, yellow, green, blue, etc. So I'm going to make this one look exactly like that. Start with the brown. You want to look on this and find where there's some kind of marking of where pin 1 is. So I'm just going to copy this one exactly. And they mark it by having this little tab there. So let's put our tab there. Stretch that out. put that through. I usually like to put it through a little bit extra just so I know that I know that I know. Now we just have to squash this. So I got a vise over there. Let's go get the vise. Hang on a minute.
Hey, how are you?
Hey. It's a good tool for that. Oh, it's really starting to fill up with people here. Hey, Spencer. Jaws. Now just making sure the alignment is good. Put it right in there. Try not to pinch my own skin. And tighten it. Ta-da. Okay, my battery's getting low on my phone and people are showing up, so probably gonna have to cut this short. But what we have now is we got this at one end and then we have some wires here. So the next steps are to cut and strip all these wires and then connect them up to the 5 pins there. Then I'm gonna do the interboard connection to go from board to board to board. And then I'm gonna hook it up to the synthesizer. So let's just, so let's just close this out now. I'm just going to spend the last few minutes of this video here separating all these. So when I work with ribbon cable, my strategy, one thing I like to do, see, is that going to focus for us? It just may. I like to separate them all just like that with the diagonal cutters. Probably some tool that splits them all at once. But I don't have it. I don't know it. And I don't need it. Just go like this. All right. Beautiful. Now I'm just going to find the wires and strip it. Find the wire cutters. The wire strippers. Here we go. These look just a little bit big, but let's try it anyway. Turn on the small size. Yeah, that is too big. Hang on. Okay, I can't find the strippers I need. Can anyone on the internet give me a pair? Just send me over some. I think what I'm going to do instead, just use these. I'm going to twist it, every single one. Just like my dad showed me when I was a little kid, I remember. God, I must have been, I don't know, 5 years old or so. I remember him showing me strip it. And then you just start twisting it. Doesn't matter what else is going on in the room. As soon as you cut it, you just start twisting it so it doesn't get frayed. Those cherry... Alright, we got a question. Those cherry switches, do they have built-in debouncing? No, I don't think so. I don't recall seeing that as a feature. Probably going to have to be done in software. Maybe that's what some of the mechanical action does. If you Google cherry switch comparison, or you don't have to Google it, use DuckDuckGo, don't use Google actually. You'll find a bunch of pictures that switch enthusiasts, I'm not making this up, have made to describe the differences between all of the different switches. Of course, you can read the spec sheets, but it's not laid out as clearly as the hobbyists. And maybe that's what some of the clicking does. You know, like I said, these switches, you press it and it's just going to travel right down to the bottom quietly. And very evenly and very lightly. Some of them you press and it goes like click, 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 click. You know, like those old science fiction movies. They get like the computer scientist to save the day and is at the keyboard going clack, 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 clack. That is exactly what you don't want on an instrument, because you'd be competing with the sound, right? In a music instrument, you're trying to make euphonious, mellifluous timbres. You don't necessarily want all that clicking in there. Oh, I just read the funniest comment. AKA Media System says, the clicky ones are associated with the passive-aggressive coders at work. I know those people. Definitely not for my current job. But, you know, other places I've worked, you ask someone a question, they'll say, clack, 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 clack. Okay. I saw we just had a second viewer. And so welcome. Now that we've got, so for the second viewer, I'll just catch you up on what we've been doing. This is the instrument guts here in the background. All right, don't get dizzy. I'm going to move that. We assembled these tonight, soldered them all up. They're going to attach to the synthesizer board with this guy here, which is a 2x5 pin connector. And there's all the random elements. So let's see. I have a paper here that says how these things are wired. Let me grab that. Alright, so this is my highly official documentation where I say white, purple, green, orange. That's for CEGB. And then they're all, the common one to that part of the matrix is red. So that means this here, the next one, CEGB, the next section, and the one after that, they all go white, purple, green, orange. And then they have the row selector, which is red, brown, and I don't know the other one. Have to bust into the code to design that. But let's pull these colors out first. White, purple, green, orange. It's got white here. Purple. And there's the green. And there's the orange. Okay. So we know that we're going to need those 4 wires. You know, the keyboard doesn't actually use all 10, by the way. And then we know that we're going to need, let's see, red and brown. So, okay, those are conveniently located right here. These rest aren't involved yet. Let's just move them out of the way. And now, on the bottom of the circuit board, I've got, I don't know if you can see that, but I've got numbers. 1, 2, 3, 4. So I believe 1, 2, 3, 4 goes with CEGB. And those numbers should match that up here. I'm going to do a little more soldering here. And if this goes out before I'm done, it's probably just the battery. I'm warning you, I got message the battery's low. But that's part of the fun. Okay, so let's just give these another twist. White, purple, green, and orange. Now these are all actually a little bit too long. It's kind of easier to actually strip them and make them too long and then trim them down to size, believe it or not. So that's what I'm going to do now, because these are all going to go into there. So we'll go. By the way, this isn't the best way to do this, but there are ways to design it. I could have put another connector over on this side, but we're just kind of restoring this instrument, not redesigning it. I would love to redesign it, and I have been redesigning one on the side over the years. This is where we are for now. So for something like this, I found you lose a lot of strength if you try to poke the wire through. So for this, it's actually kind of better to put a blob of solder on there and then attach the wire to it. So for that, I'm going to tin all the pads, and then I'm going to tin all the wires. And you notice there's a couple, you'll notice there's a couple holes here. These holes are actually so you can put a zip tie through there for strain relief. So first, I'm going to trim these just a little bit more now that I see how much space we have on the board. Okay, this is going to be about 2 millimeters long. 4, 5, 6. Okay. Now we're going to go and we're going to tin all these on the board.
Well, I just bought like $100 of Alpha stuff from Container Store. Just housed like $5 worth of stuff.
2,
They stopped selling these, so I can't
3,
buy them. They don't make it.
4, 5. So now remember the order. White, purple, green, orange. White, purple, green, orange. Actually, I'm going to tin all of these as well. So for that, I just like to have the solder up in the air. The solder on the end and just run it over.
Yeah, whatever you have, we could work on it. I don't have anything specific. I have like millions of projects that I want to document. Nope. Where's my box?
Okay, there we go. All tinned. So the advantage of doing it that way, oh boy, battery critically low. People are probably going to get booted offline any second now, just so you know. But thanks for showing up in the meantime. Really appreciate the attention. Don't forget to like and subscribe and click ring. So I'm just going to keep documenting the entire restoration and then maybe play some music at the end. And I'll be talking about where to find the instructions and everything to build your own, etc. So now let's solder. White. Actually, I'm going to start from the far end with orange. Actually, that's red out there. Green. Purple. White. Ah, yes. Okay, I can barely see this because my screen is so dim. Oh, it's Al! Hey! What's up, Al? Good to see you. Let's see. Yeah, this is nice. We got the 5 wires attached. Let's see. So that's 1 for each key, and then there's the row connection. Remember, we got this guy here. So the way this is going to attach, just right onto here. Yes. Okay, so as I've said, so in theory, we should be able to test the system now. we don't need all 12 or all 8 keys in order to do it. We should just be able to do it with this. Now that said, I found that I'm going to have to do just a little bit of effort to get the system going again. So I'm going to zoom out. I'm going to have to do some debugging here. I know we've got the generator here. We know it's going to charge this. So let's hook up our oscilloscope and just verify that we're getting power out of this in general. So we go to the ground and then to the positive supply. Oh boy, I have never used this particular oscilloscope before. Probably be smarter to use a multimeter at this point. Oh no, we got something. Let's take a look. I'm going to swing over to the oscilloscope. So you see, we got that little voltage there. So turn off channel 2. There we go. That's our waveform. And what I believe we're looking at, we're at 2 volts per division. That's 0, so we got like maybe a half a volt there. So let's pump up the generator. Oh yeah, definitely. Ah, that was beautiful. So you could see it draining. So I'm gonna slide it down a little bit. There we go. So there's about 2 volts in there now, residual. Pump it like that. Now it's shooting off the scale. I'm going to attempt to change that here. It's always fun using an oscilloscope for the first time. Okay. We'll pump it again. See, we got some real high voltage there. Now this is 10 volts per segment. So I'm seeing... Alright, if I'm reading this right, we're seeing almost 80 volts? That seems a little unlikely. Wonder if we don't have the scale wrong on the probe or something like that. So that's it. No, okay, the probe's saying 10x, and that's saying 10x. Okay, the only thing I don't like is that charge isn't really staying on there. So I'm going to temporarily disconnect the speaker from that, and I'm maybe going to disconnect the regulator. Now when I pump, that charge should stay there. You see, it's not. Ah, crummy buttons.